بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الديناميكا وهو تابع الشغل المبذول. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in dynamic subject. Its title follow the work done. My dear student, look at the first example. A body of mass 2 grams moved on the plane XOY under effect of the force F equals 8I plus 4G. My dear student, look again. A body of mass 2 grams moved on the plane XOY under effect of the force F 8I plus 4G. Displacement AT square plus 5 inside bracket I plus BT square plus 2 inside bracket J, we are measured in centimeters and T in second. Find the value of A and B. Then calculate the work done by the force F in the interval from t equals 0 till t equals 5. My dear student, the required A and B. We have two unknown variables, A and B. Then calculate the work done by the force in the interval when t equals 0 till t equals 5. Look at solution. My dear student, we know that S displacement equals R minus R naught. We have the relation R equals, by substitution R naught about t equals 0, then displacement became AT square I plus bracket contains BT square plus TJ. My dear student, this equation number 1. At the first, find the velocity by using differentiation displacement respect to time t. Therefore, V equals 2AT I plus 2BT plus 1. Why? My dear student, we know S equals AT square plus BT square plus T J. As the first, the velocity V ds over dt, we find 2AT. Why? Because differentiation of t square equals tt and differentiation of t equals 1. Therefore, displacement is 2AT I vector plus 2BT plus 1 J vector. After that, what is the acceleration? dV over dt. By using differentiation velocity respect to time t, acceleration became 2AI plus 2BJ. Therefore, we know that, my dear student, the force equals ma. By using this equation, we have left hand side from given the force 8I plus 4J. Right hand side, mass equals 2, acceleration 2AI plus 2BJ. Therefore, we have left hand side and the right hand side. Look at left hand side, coefficient of I 8, but in right hand side, coefficient of I 4a. Then the value of a equals 2. Also, the coefficient of j, left hand side 4, right hand side 4b. Therefore, b equals 1. My dear student, then A equals 2 by using 4 equal 4B, B equals 1. The value of A equals 2, the value of B equals 1. This is the first required. By substitution about A and B in displacement, the relation S equals 2t squared I plus t squared plus t inside bracket J. Therefore, we know that the work done F dot S. What is the F? 8 4, 8 4, 8I for J. We can put the force from fundamental vectors to component of the bracket 8 4. Also S 2t squared, t squared plus t. We multiply 8 first times first plus second times second, or x1 times x2 plus y1 times y2. The work done became 16t squared plus 4t squared plus 4t equals 20t squared plus 4t. This is the work done in t second. At t equals 0, by substitution about t equals 0, therefore the work equals 0. At t equals 5, by substitution t equals 5, the work is 20 times 5 squared plus 4 times 5. Answer is 520. Therefore, the work done W2 minus W1. Answer is 520 minus 0 equals 520 H. Another example. My dear student, particle moves in a straight line under action of the force magnitude 400 dyne acting in the direction of motion. We know that magnitude of the force in this example 400 dyne. Remark, my dear student, we have two types of the force. The force by fundamental vector, the force by using magnitude dyne 400. Find the work done by this force during displacement of magnitude 300 centimeter. Solution. My dear student, in this case, the work done equals F times S. We know that F equals 400, S is 300, answer is 120,000 erg. Another example. My dear student, we know that we have two types of the force. The first force by using fundamental vector by using I and J. But the second type of the force of magnitude of the force by using Newton or dyne. In this case, my dear student, we know that the work done equals F times S. If know the value of the force and the value of S displacement by using times or product of the force times S, find the value of the work done. Other type, my dear student, if we know that mass of the body and the displacement, we need the force. How to find the force, my dear student? The force equals m times a. M, its symbol or denoted by the mass of the body, and a is acceleration. In this case, my dear student, we need acceleration. Acceleration equals dv over dt, or differentiation of velocity respect to time t, or find the second derivative of displacement respect to time t. Displacement is S vector. When we find second derivative of S vector respect to time t is acceleration, or by using other method we find acceleration A vector equals dv over dt. Then when the required, the work done, and from given displacement only, we find the value of velocity by using ds over dt. After that we find acceleration A by using dv over dt. After that multiply m times A to calculate the force of the body. By using F times S is the work done. My dear student, look at the next example. Tram car is pulled by horizontal rope inclined at angle of 60 degree to tram track, and it moved distance of 15 meters. My dear student, in our life, this example, each day we see it. A tram car is pulled by horizontal rope inclined at an angle of 60 degrees to the tram track, and it moved distant of 15 meters. If the tension in the rope is equals to 150 kilogram weight, what is the required, my dear student? Find the work done by the tension force measured in erg. The required, find the work done by the tension force measured in erg. Solution. My dear student, look at, we resolve 150, this is tram track, by using 150 cosine theta in horizontal. Therefore, the work done in this case F cosine theta times S. F 150 is the tension, 60 inclination angle by tram track. Therefore, my dear student, F equals 150 times 1000 times 980. This is the force, multiply cosine 60 times 100, 1500. Answer is 11,025 times 10 power 7 equals, by using this erg, by using joule. What is the relation between joule and the erg? Excellent student. Joule equals 10 power 7 erg. When convert from erg to joule, divided by 10 over 7. Why? What is the biggest, joule or erg? Joule more than erg. Why? Because joule equals 10 power 7. Joule from equals Newton dot meter, but erg dyne dot centimeter. And we know that Newton equals 10 power 5 dyne, but joule equals 10 power 7 erg. When convert from erg to joule, divided by 10 power 7. Then the work done in this case equals 11,025 joule. Now we are translate to another example. A car of mass 1,500 kilogram or 1.5 ton climbs a hill at constant speed of 20 meters per second. My dear student, you have a car and climbs a hill with velocity or speed 20 meter per second. My dear student, remark, there is difference between speed and velocity. Speed is scalar, velocity is vector. In this case, my dear student, a car of mass 1,500 kilogram climbs a hill at a constant speed of 20 meter per second. If the hill is inclined to horizontal by an angle alpha, where sin alpha equals 1 over 10, find the work done by the car against gravity in 1 minute. My dear student, remark, what is the required? Find the work done by the car against gravity in 1 minute. My dear student, if the total work done by the car in this time is 24 times 10 power 5, find resistance to motion. Very important, required. My dear student, take care. If the total work done by the car in this time 24 times 10 power 5, find the resistance of to motion. My dear student, in this case, the required find the resistance to motion. Solution. Look at, my dear student, distance in 1 meter equal 60 times 20 equals 1,200 meter. In 1 meter equal 60 times 20 times equals 1,200 meter. This is distance. The height raised by car by using 1,200 times 1 over 10 equals this height 120 meter. The height equals 1,200 times sine 1 over 10 by using calculator equals 1,020 meter equals 120 meter. The height raised by a car. The car climbed to a hill. Hill has a height. What is the height? By using right angle triangle, by using sine, cosine 10, and the length of 1,200, distance in 1 meter, in 1 minute, 1,200 times 1 over 10 equals 120 meter. This is the height of the hill. Work against gravity by using F dot S equals 1,500. This is the mass. MA 9.8 times 120. MA S. By using S is height. My dear student, the work done in this case, we find the value of MA or the force. In this case, A is acceleration 9.8 or gravity. Work against gravity 9.8 and the height 120, but the force 1,500. MA, the force MA 1,500 times 9.8 times 120 represents a height or displacement equals 17.64 times 10 power 5 joule. My dear student, in this case, the resistance equals R, B equals R plus mg sine theta. In this case, mg sine theta, m equals 1500, g 9.8, gravity sine theta 1 over 10. R plus right hand side 1470. Therefore, by using the work done by the car equals B times S. The work done from given is 24 times 10 power 5. B times S equals R plus 1470 inside bracket times S 1200. Then resistance by using left hand side and right hand side, therefore R equals 503 Newton. My dear student, this example is very important. The required in this example, what is the resistance of motion of the car? We have a car climb a hill, but this hill we have not the height of the hill or the distance which car moved at. By using length and sine to find the height, this height represents S or displacement. But what is the F? F in this case equal M times A or M times G. In this case under gravity, G equal 9.8. M is mass. After that, we find the value of F by using M times A, then by using M times A times S or times height to find the value of the work done. After we know the work done, we know that the work done equals B times S. B in this case equal resistance plus MA sine theta. After that, by using left hand side and right hand side to find the value of resistance. My dear student, look at the next example. My dear student, a body of mass 5 kg is moving vertically in water against resistance 15 Newton for 10 seconds. My dear student, we have body of mass 5 kg is moving vertically in water against resistance 15 Newton for 10 seconds. Find the distance traveled, this number 1. Find the work done against resistance. My dear student, third require, find the work done by actual force. Solution. In this case, my dear student, by using equation of motion mg minus r equals ma. Why? Because in this case, my dear student, the body move in water, then mg, the motion is downward. mg minus r equals ma. Therefore, by using substitution, m equals 5, gravity force 9.8, resistance 15 Newton R, and m equals 5 to find the value of acceleration. mg minus r equals ma, therefore acceleration is 6.8 meter per second square. Since, my dear student, from the second rule, S equals V naught t or ut plus half at square. V naught t or ut is initial velocity, t time, acceleration A, S displacement. This relation between displacement and velocity or initial velocity and acceleration respect time t. Therefore, we know that in this case t equals 10, answer is 34 meter. The work done in this case, my dear student, equal R times S. R equal 15, S 34, answer is 510 joule. Since F equals MA, we know that M equals 5, but A is 6.8, then the force is 34 Newton. My dear student, we know that W equal R times S, 34 times 34, answer is 1156 joule. Now we are translate to another example. Horizontal force F act on a body of mass 1.5 kilogram placed on horizontal plane. It moved it from rest a distance 196 centimeter in 7 seconds. Against constant resistance equals 1/10 the weight of the body. Find the force F, also the work done by the force in joule. Look at solution. My dear student, we know that S equals UT or V naught T plus half AT square. By using displacement equals 196, acceleration A, T equals 7, therefore acceleration equals 196 times 2 over 49 equals 8 centimeter per second square. After that, F minus R equals MA. We know that R equals 1/10 from its body weight. 3/2 times 9.8 equals M 3/2 times 8/100. Therefore, F equals 1.47 plus 0.12. Answer is 1.59 Newton. The work done in this case R times S. Answer is 3.1147 joule. My dear student, by the end of the lesson, I am very too happy to spend such time with you. Thank you. Goodbye.